that you might fall asleep after lunch. I am worrying that I might fall asleep because I have 9 hours of difference. I'm coming from Belgium, so hopefully I will stay early. So I wanted to talk about something that is very important. We see it everywhere, but I think we don't talk a lot about is how do we monitor business processes. They are running as black boxes most of the time, and this is very annoying. So I wanted also to pick an example, a fairly complex example to work on that would make it more easy to understand. So I am an enterprise architect for Toyota Motor Europe. I have extensive experience working with distributed systems, complex domains, etc. And I am in the streaming area for quite a long time. It's a passionate subject and extremely interesting. I discovered RisingWave as part of the ecosystem, and I thought it might be a good fit for this. So, monitoring complex business processes is not salt and pepper. You cannot just put it afterwards. You have to build your solution with that in mind. And so you have to architect in such a way that the byproduct is easy business monitoring. So I took a very complex area. This is how you maintain aircraft engines. I thought it was very proper for that. So it's a multi-billion-dollar industry, very critical safety, and very strong regulations. So the companies, the airliners, they spend a lot of money on that. So MRO scheduling is one of the areas where AI is supposed to bring a lot of benefits because how do you space the schedule for these maintenances is very important for the cost. So we have three cases. The first thing is on wing. You leave the engine on the wing. You do something very quickly, a few hours, a couple of days, and it's out to fly again. The second is off wing. You have to bring it down. It's more complex. It's for more serious damages, and it takes from 15 to 35 days. The big monster is called overhaul. You disassemble everything, and then we're talking about approximately 2,000 parts, and you basically make it brand new. That's more than 2 months. So let's talk about the overhaul. I try to find a picture that will speak immediately about the situation. So on the left, we have an engine that is a bit pale. It's not in very good health. I try to show this with colors. It's much easier. See the white rectangles. These are subcomponents, and the little rectangles are the 2,000 little parts. When you do the overhaul, you disassemble completely the engine, which is on the right, and at the end, you get an almost brand new engine ready to ride. Yes, 15,000 miles more, hours more. So let's get into the details of that. How does it work? We inspect the engine. Then we are disassembling, and we inspect again. And we continue this until we broke it into all elementary 2,000 parts. Notice the inspections. They happen in every step. I have shortened the steps for the sake of clarity, but there's much more. So then we clean them, we inspect them again, and when we refurbish, which means that we examine them, the wear that they have and all that, and in that process we discover the ones that have the X on them, which are defective. And these are important components that we cannot defect. There's limited lifespan parts. and we have to replace them. So when we replace those, we start the assembly, inspecting again, and finally we test. So if you ever look at this, this is something that's happening for more than 2 months. And the owner of the engine is waiting. So how can we follow this up? How are we going to see what is happening on every state? So notice that on every little colored rectangle, when we let it go through this pipeline, this processing, it produces an amazing amount of data. So you see all these actions that are up there, they produce a lot of data. And so we also need to do a lot of reasoning while we are decomposing it, and afterwards when we are composing it, in order to take decisions, to involve other parties, to see inventories and all that. So let's see what are we looking at. So we have different data sources, right? Data are collected for many, many different places in various formats. And we have to store this data. We have to store this data, for example, because we have very strict regulations. We have to be able to prove things along the way. We have to control and workflow. This is a very complex process. How do we control this? So we have real-time control. We have to apply the core business processes and the workflows, approval processes, of course, and alerts and inspections. Then we need insights and reporting. So the inventory tracking is very important. When we want to replace the little defective rectangles, we have to have the components in question. We have to worry about maintenance schedules. We have to track the cost, and we have to have performance reports. At the end of the story also, we need, I see neither here or here. So workflow optimization and the scheduling of MROs. So what are the challenges? We have to handle large volumes of in-motion data. So really large volumes and in motion. And obviously, if it's already in motion, we don't want to stop it. We want to keep it in motion so that we process more efficient. We have to balance real-time processing and long-term storage. That's not obvious. We will see. We have to integrate diverse data sources to support event-driven architectures, obviously, to communicate with the rest of the ecosystem, real-time use cases, execute real-time event stream processing, but also complex event processing. We have to ensure that we have governance and compliance because we collect a lot of data. And we have to facilitate analytics and continuous improvement. And of course, optimize the cost management. So the last part, the cost, is everywhere. So whatever we do, we can think about optimizing cost-wise. So let's see. What are our technical requirements, finally? So we have to be able to connect to many different data sources and recognize many different data formats and eventually apply simple transformation logic. That would mean that we collect data from different sources, we apply some transformations to make them different and push them somewhere else. We have to store and at the same time keep the data in motion. So this is the interesting part. In Pulsar, we have the possibility to store the data in a topic for a desired period of time. What we don't want is to store the data somewhere else and then pull them back again to put them in motion. And also, we want support for both queuing and streaming. So processing-wise, we should distinct two different situations: stream processing in general, and materialized views, and of course data streams are stable, so we will talk a bit later about that. So stream processing and materialized views. Why do I do the separation for that? If we go to our previous picture, we see that all this pipeline is a typical situation of stream processing. We have data that are coming in constantly, and we can use a stream processing engine to be very quick, very precise, because we need consistency. We want to make sure that all the actions that are happening are consistent. Now, outside that ecosystem, we will need to collect monitoring information while we do the processing, and this is something different from the data that we process from beginning to the end, which means that the monitoring information that we collect, we mainly need it to produce materialized views. So let's go back to this. So governance. So we need data schema validation. We need the data lineage. We want to know where our data are coming from. This is extremely important, and it's related also to the monitoring part. Security control, who is accessing the data? Do we know? Can we have fine-grained control? And multi-tenancy. So this is so important because of the amount of data, first, and second, about the different nature of the data. So not all the data belong in the same data domain. And that means that we should be able to separate them in a meaningful manner, and combined with the security part, be able to give selective access to the different domains to the appropriate users for the different use cases. So the technologies, you know them already. The Stream native platform provides Kafka and Pulsar storage and the known streaming capabilities. And Verica provides the Flink capabilities. So we will need these two for the part that I talked about just before, storing the data in the proper manner and also processing the data. The capability to connect to different sources and to export to other things is fundamental also. So we have in one place all that we need for this part. Now let's have a look at RisingWave, who is a streaming database. So it will take our streams, and it will help us, so very generally, to produce materialized views. Why don't we push the data to Elasticsearch? Latency, a lot of effort. We have to guarantee the consistency. Believe me, you probably know it already, it's not very easy to do that. So I will not go into details. We have somebody here that can give us much more details on that. So these two technologies, three actually technologies, are going to provide us all the necessary elements to do the job. So let's see. The implementation. When we look at this, and we know that each of these little rectangles means a lot of data, the first thing to do is to structure this data properly. The types of the components are not always the same, so we will need to organize them into different topics. So we create in that manner several data products. So all the data that are associated with the different types of components are stored in the proper topics, and we give the appropriate retention, which is probably long due to the regulatory compliance and the audit is eventually. So why data products? Because we need a very good definition of what we store so that they can be reused in the whole process. So the second part, so on the connecting part, we connect to the different data sources using all the connector ecosystem of Pulsar and Stream Native. We can recognize different data formats because we have the capability through the connectors to differentiate the sources. And we can apply simple transformation logic. That would be very interesting when we try to curate the data and cleanse the data that we receive from the outside into our pipeline. So regarding the storage, our data products will keep the data in motion because they are always in the topics, always available. We don't need to store them somewhere else and with a given retention. So we support both queuing and streaming and also long-term storage. So we don't have any penalties of getting the data stored and retrieving them afterwards. So real-time use cases, as I said before, is much easier to perform. So on the processing part, the stream processing part is going to be covered by Flink. The Flink operators are very good in taking all this data that we process in the complex picture, use joins, use all these tools that we have, and at the same time, during this processing, we can collect monitoring data that are adequate for the business monitoring of the system. So if we send this extra monitoring data into other topics, we create monitoring data products in the same manner that we created the operational data products on the previous conversation. That is very important. So we use one tool to create this data. And of course, we can have them available as a data stream, the data streams as tables in the lake storage of Pulsar. But most importantly, we can make them available to RisingWave in order to create materialized views. And now we will do a little sidetrack to see what's happening with the materialized views, why we need that. So we have materialized views that are the result of real-time processing. So this is something that we don't have to do ourselves. Our data, our materialized views, the final result will be updated very, very, very quickly in milliseconds or seconds. This is a very big deal. I have seen cases where storing data results into seeing the data that you stored in a few days. You see, this is non-applicable in these cases. So we have the capability to define the metrics that we need using simple SQL. So that means that we can give this responsibility to teams that have lighter capabilities than the low-level and the extreme Java skills that we need to work with Flink. And we can support complex calculations so that we can construct different kinds of metrics from the data, the monitoring data that we have collected. And all these are consistent and scalable. By consistent, I mean coming from the same source and corresponding to the same time. This is, I don't know if I make it clear enough. If you get two different metrics from the same source, you have to make sure that the time it corresponds. Otherwise, it doesn't really make sense. This is not that easy to obtain, and RisingWave does that quite well. So, Postgres SQL compatible, that makes a big difference. Nested materialized views. This is a killer feature. We have three basic benefits from that. So reduced complexity because our logic is decomposed. Improved consistency because we access the same version of the data. And last but not least, enhance maintainability. If we change something in the whole materialized view pipeline, let's say, it gets updated in the related views. So at the end of the story, we need, the data schema validation is ensured through the schema registry that Pulsar gives us. We have this option. The data lineage, we get it already with what I mentioned. The security control is the security control of Pulsar. We all know how efficient it is. And the multi-tenancy, indeed, is there. So actually, these three technologies is a perfect fit for our use case. So how does it translate to developers? Reusable data streams, simplified operations, focus on the application and innovation, and accelerated productivity. And to the business, it gives real-time use cases. It makes them possible. A clear insight on complex business processes. They will be extremely happy for that. Consistent and secure. And of course, AI ready. So that was it. Yes.
Hi. I probably didn't follow this part where you said there are like 2,000 components and like how did you convert that to 2,000 different pipelines? And I think you also mentioned it's like large volume of in-motion data. So I got confused where you said there are 2,000 components and this whole process takes 35 days, right?
Yes. Let me go back. Right? In this picture. So these little rectangles correspond to the individual components of an engine. This is schematic. It's not precise. So what I mean by this is that when you decompose it, you get 2,000 of those of different types. So when you process these components on any of the stages, for example, the word inspection produces data automatically. This is not just words, it's a lot of data that are involved. And many others. I keep it simple because it's an extremely complex process. So all this data have to be collected. They are associated to this component and they are being collected. When you are disassembling it or reassembling it, you have to take into account relationships. So for example, if all these are finished but these two are not, you cannot assemble. So it's a very simple example. So all these are managed through Flink pipelines.
Yeah, I follow everything else, but
Okay.
what I'm not able to understand is the scale of the problem, because I think to me it seems like a very small scale to apply a streaming solution on top.
Oh, okay, yeah, but you're not doing one engine. You are doing a lot of engines. So, okay, that's a very good question. You don't want to do this processing just because you have a lot of data. So you produce a lot of data proportionally for each individual component, but you also want to have a mechanism that is very precise, that gives you consistency when you do all that. So indeed, you can skip the technologies and you can do it with individual applications. Agree. That's what happens most of the time. But then, consistency on the pipeline, you have to guarantee it yourself. This is very difficult to do.
Can you explain how it was done before streaming? Like what was the tech stack look like and was it even possible?
It wasn't even possible. So in many cases, when we see, say, business monitoring, it's fake. You get some information. For example, if you imagine that you have 5 silos and you do the pipeline by communicating with the 5 silos. This is a very common situation, not only in that domain, in many domains, in manufacturing. So how are you going to guarantee that the information that you are collecting is timely? It's very difficult.
Is it fair to say this is like a digital twin you're creating of the system?
Yes.
And you're collecting event data for each of the components
Yes.
of its health and how it is.
Exactly, exactly. This is a very big deal because, yes.
Question, like the materialized views you said, like how big those get?
Sorry, can you please repeat?
The materialized views you
Yes.
said, like to like how big those get, like in the pipeline, like do they get?
Okay, I will repeat. This is also a good question. So, when we are collecting the data for this, and or all the others, we also have we do that in a Flink operator, right? When we are processing all this data and we do the reasoning in a Flink operator, we can also produce data, right? When these are monitoring data, and it can be a lot of data. In some cases, in some processing, you have a lot more monitoring data than the actual data that you're processing for various reasons. And you can store them into topics. Okay? So you make them available. You are not creating materialized views yet. But you are creating the data. So the first thing is create the data. When you do that, the data have a specific schema. They are very well defined, okay, as usual, as all the data that we manage here. And so it's a data product. It's ready to consume. You document it. From that point on, you can leave RisingWave take control of these topics. So it's a good question because I forgot to tell you something. So we have one, the horizontal process that is running, but also we have the side part. It is collecting all the monitoring data and delivering it to RisingWave to get the monitoring information. These are two different things. Does it make sense?
Yeah.
Yes.
Are you leveraging any EPCIS data for process transparency?
No, it's an example that I took. We can talk outside, but yeah. Yes.
If you have time, what is the role of Flink and RisingWave? Like, why did you choose to use both? And like, why didn't you? I think you mentioned for some use cases you used RisingWave for like the SQL, like defining the monitoring data in it. So where is the boundary between the two? Like, where do you use Flink and where do you use RisingWave?
Yeah, it's a very good question. So you want to use Flink when you have to do a lot of things using code. You have complex reasoning to do that you would have, let's say, it will be a bit harder to do with the UDFs in RisingWave. So this pipeline requires, it's not simple. It requires a lot of complex coding, complex requirements, complex combinations. So to keep it safe, you do it with Flink. And you also want to use a team that is knowing Java very well. So it's different competencies. So the team that does this and the team that worries about the monitoring are not the same necessarily. So from the moment that you manage to export all this monitoring data, you just let them in the hands of, let's say, a data team, so that knows what to do. There is also an interesting part there. since I mentioned that your metrics are actually SQL queries on the materialized views, your data team can modify them, and you can play with the requirements according to the business, but it does not interfere with the actual process of performing this maintenance correctly. And you know, getting from there to the final picture. Does it answer your question?
Yeah, thank you.
You're welcome.
Maybe one follow-up.
Yeah.
If there is a SQL, like Flink has SQL interface, did you?
Yeah, but
Is it primarily not to interfere with the processing, or there were problems with?
you don't want to have it in there. Yes, exactly that. You want to have it independent. You want to leave the other team define the metrics and modify them whatever, because this is something that is that is changing frequently. The process is not changing frequently on the other side.
Thank you.
One quick question.
Sure.
So it looks like a complicated system to me. Like, you know, if there's a, like, you know, recovery where you have to like redrive, like, you know, after a failure, like a recovery process, would like, what's the experience like? You know, is it gets from the way you described it, it would be hard to recover, like, you know.
When you have a failure, but where in this processing?
Yeah.
Well, you can have failures in Flink operators, indeed, but you don't lose data. Your consistency is guaranteed.
You can always restart.
Yeah, so if I understand well, you say, okay, you have a Flink job, for example, for this. You have the different operators. Let's simplify it. The different operators that are doing this. Something is failing. Okay, but a Flink recovers. So it has the checkpointing mechanism. You have to pay attention. So this is also related to that question. Why? Because you need a specialized team that has the knowledge to write a Flink job that is performant and also reliable. But Flink gives you the tool. So the interesting thing also is that it guarantees the consistency to the pipeline that you're running here, but also to the side outputs that you produce with the monitoring data. So you are not going to be in a situation when your process is running, but there's no monitoring data that are produced. Okay, makes sense? That is exactly why. So if you can guarantee that the data are produced and are structured, so proper schemas, proper definition, then you take it from there. So the two things become possible and dissociated. Here you produce the data, and there on the RisingWave side, you create the different materialized views or materialized views of the materialized views, and so on and so forth. And you take control of the metrics outside of this. Any more questions? Thank you very much.